Welcome to the WTR Small Cap Spotlight Podcast. I'm your host, Tim Gerdeman, Vice Chair and Co-founder and Chief Marketing Officer of Water Tower Research. In today's podcast episode, I'm being joined by Eric Robinson, Senior Vice President of Operations, and Joe Wong, Chief Technology Officer at ARQ Inc., Nasdaq, ticker symbol ARQ. ARQ is an environmental tech company that produces activated carbon products that reduce or reverse such environmental liabilities as mercury emissions from coal-fired plants and so-called forever chemicals from public drinking water systems. Also joining is my WTR Equity Research colleague, Peter Gastreich. Gentlemen, good morning and thank you for joining today's podcast.
Good morning.
Good morning, Tim.
Morning, Tim.
Eric, let me kick things off with you. Could you please tell listeners about your background and what brought you back to the company at this particular moment in time?
Yeah, so thanks, Tim. I've been working in the industry for 42 years, and I've run plants all over the world, including the Red River facility. I was here for 6.5, 7 years previously, late stage startup at that point. I built some great relationships here, including with my friend Joe Wong, and a number of other people here. When I retired, I started consulting, and ARC reached out to me and asked for some help. And I began consulting here with the team, and that then led to me coming back as an employee to help get this project back on track.
Great. Thank you for that color. And then, Joe, moving on to you for a moment as ARC's Chief Technology Officer, can you please walk listeners through your background and what your team's role is within the company?
Sure, Tim. Thank you for having me. Yes, I'm a chemical engineer by academician. I've been in the activated carbon industry for 39 years and counting. And yes, I'm in a very fortunate place. Technology is a driver for us turning ideas, technical ideas, product ideas into cash. So I sit at the intersection of both technology, operations, and commercial introductions to customers. My team is involved in a myriad of activities, getting new products from the development stages all the way into the customer's hands. So we basically solve customer issues and create products that clean up the environment. So that's what my team does.
And then finally, before I turn it over to Peter to ask a few questions, for listeners new to the space, Joe, what exactly is activated carbon? How is it made? And I think more importantly, why is it so effective at removing pollutants from air and water?
Sure. You could think of activated carbon as a super sponge, but it's quite different. So, for example, if you could think of a sponge where you absorb the water and you squeeze a sponge and the water doesn't come out, so that's what it does. An activated carbon is like a sponge, captures contaminants and holds onto the contaminants and concentrates the contaminants so that you can remove it from the water, remove it from the air. And what makes activated carbon so effective is that it has what we call high surface area and high pores, holes that these contaminants can reside in and don't come out.
Great. That's a wonderful analogy, actually. So, Peter, I'll turn it over to you.
Thanks very much, Tim. So, Joe, yeah, we'll continue with you on activated carbon here.
Sure.
So, ARC produces different types of activated carbon. Could you explain for our listeners, the differences between them, what each is used for and why the, feedstock selection is important?
Sure. Yeah, we make predominantly two types of forms of activated carbon. We make a powdered activated carbon, which is typically not quite the size of the diameter of your hair, fine granular powdered carbons. And then we also make a granular activated carbon, which is a larger size particulate of carbon that usually is used in vessels and columns where you're passing water through the vessel and the granular activated carbon. In the powdered carbon application, you're actually spraying the carbon into the water or the gas to remove to capture the contaminant, whereas in the granular, you're passing the water or the air through a column of the activated carbon. So size is the difference between the different forms that we make.
And I think it's important for our listeners to understand that activated carbon is not a commodity. It's really more of a specialty product. What is it that makes it, technically differentiated, and how does your team work with customers to tailor, your products to those specific applications?
Yeah, that's a good question. Different customers, whether they're in the water space or the coal-fired power plant, flue gas markets, their contaminants are different. And even different sites that burn different types of coal or different drinking waters have different contaminants at different contamination levels. And so we have to design the carbon to match those contaminants and the contaminant size, the type of polarity in the contaminants. And so that gives us an opportunity to customize the activated carbon to really have a strong affinity to remove the contaminants. So that's where the opportunity comes, is that different contaminants require different chemistries, different physical forms of our carbon to be effective. And so we're able to custom make the carbon by changing the surface area, the chemistry on the surface of the carbon, and the pore size, the size of the holes that we make in the activated carbon.
So we're going to get to Eric on the next question, but just one more here for you, Joe, on this. So could you walk us through kind of practically, how does, activated carbon actually work at a water utility, from detecting PFAS problem to selecting treatment technology? What does the process kind of look like?
Okay. Well, you could think of a water treatment facility as a mini chemical plant. You take the dirty water comes in, whether it comes from groundwater or surface water, lakes, rivers, it's dirty water. When it comes into the municipal water site, it gets treated. Whether the first thing may happen is you remove the particulates, the particles, maybe by a filtration step. Then you may add chemical additives to what we call coagulate the particulates and have them drop out. You may add disinfectants. You may treat the dirty water with activated carbon vessel to remove PFAS, taste and odor components. You may spray that powdered activated carbon into a water basin or a vessel to remove the contaminants. So there's just a sequence of different steps that occur in a particular water site to go from dirty water to clean water. Okay, so that's the way you got to look at it. And so different sites use different steps or are in different sequences. So we got to understand what the customer sites require and what their contaminants are.
Okay, thanks for that, Joe. That's a great overview. And I'd just like to turn to Eric here. So if we look, a couple of years ago, the PAC business was really dominated by mercury control at plants, but we see sort of, quarter by quarter for some time here that customer mix has really been shifting, right? So, from an operational standpoint, what levers are you pulling to kind of optimize that Red River facility for this broader and more diverse set of markets?
One of the really exciting things about ARQ, when I first came here in 2012, we made two different products, two at Red River. Today, we make 24. And a lot of that is a strong collaboration between me and the operating team and Joe and the R&D team. Joe's team is really, really good at being able to come up with customized products to help our customers deal with their specific problems. What we have to do here on the operating side is work with his team, work together to translate that into a production process that can make it at high volumes, good efficiencies, and a cost that makes good sense. And so that's what we do. That's what we're organized around. That's how we respond to the marketplace. And that is what's necessary in a site like this to be wildly successful, is to be able to adapt as opposed to just lock in on the two things you want to make. We have to have the ability to flex to make the 24 things our customers want and need.
And Eric, when you arrived at the Red River facility and assessed the situation with GAC, what exactly did you find? Could you kind of walk us through the design flaws that were inherited from the original engineering firm and why they proved so difficult to diagnose and fix?
Yeah, the fundamental issue that we ran into here was a miss on what the off gases were going to be from the process. We're an environmental company, and so ensuring that we are absolutely minimizing our environmental footprint by what we do is important. And so what we found, one of the things that we uncovered was just a big miss by the design firm in what those off gases were going to look like. Because of that miss, the design just didn't accommodate either both the gas flow and the conditions under which it had to be transported so we could treat it. And that caused us a number of operational issues that just were, at the end of the day, just not something we could overcome.
And something that has come up in the earnings results calls with the management has been the discovery about the thermal oxidizer and how that led to the decision to pause the GAC, production. Could you share sort of, what exactly does a thermal oxidizer do? What's the testing revealed? What has the testing revealed about the existing system's limitations, and why that finding, made continued production unworkable?
Yeah, so what a thermal oxidizer does is it basically destroys the organic compounds that are emitted from the production process. We're taking a coal-based material, and then we are cooking it, basically cooking it. And when you do that, you get a lot of volatile matter that comes off. That volatile matter needs to be destroyed, and that's what a thermal oxidizer does. It oxidizes those under high temperature and makes CO2 and water. And so that's a key portion of our emission control process, and critically important to the way that the plant needs to operate. What we found was that the thermal oxidizer that we had in place that we were using just wasn't sized properly for the types of gases that we were going to be feeding it. And that just created a problem that said this isn't going to work at the scale that we want.
So, Joe, I'd like to kind of zoom out a little bit here to look at the competitive landscape. And we know GAC demand is strong and prices rising. But why is it that the competitors, are not building more capacity? Like, could you just maybe please walk us through the supply side of this equation? Who are the main producers out there? What barriers exist for the new entrants? And where does ARQ, fit in there with its brownfield position?
Yeah, the two, as everyone knows, the two predominant granular activated carbon producers in the U.S. are Nord and Calgon Carbon. Well, let's just take a step back. Designing, constructing, and operating a granular activated carbon plant from bituminous coal is very complex and very expensive. It takes a lot of design and right equipment, right source of coal, as we found, to make this happen. So it's not just let's jump into it and get something started up in months. It takes years to construct a plant and get it done and get it started up and done right.
And now just shifting over to Eric, in terms of the path forward for GAC. So, you're now overseeing a comprehensive engineering review with a new firm and equipment provider. What are the key questions that review needs to answer, and why did the company need cost and timing estimates refined to a much tighter tolerance before being ready to commit that capital?
Yeah, so we talked about the importance of making sure that our environmental controls are robust. And that is the key here. There are a number of different design options, a number of different ways that you can go about uh, destroying those organic materials. Um, engineering is the application of science to find the economic solution to the problem. They made me memorize that 50 years ago when I was a freshman in college. So we've got to apply science to find the economic solution to the problem. There's a number of different options. We're whittling those down and getting to the design that we think is going to be the best for us. In order to do that, there's quite a bit of work that needs to be done. And the detailed engineering is what will give us an estimate that has a tolerance on it that we can live with. Don't want to just have it be me going through and saying, here's the equipment cost, therefore it's going to be about this amount to put it in. We want to know with some precision, what's that really going to cost? Important for us to get this right. You don't want to get it wrong, and because the cost of getting it wrong can be high. And so we need to be measured. We need to apply good science, and we need to be thoughtful around how we want to do this going forward. And that's what we're doing right now.
And Joe, I understand that ARQ is looking at and your team is looking at some adjacent opportunities. We don't stop with PAC and GAC production. There's some other interesting things going on. For example, I understand you're evaluating reactivation and acid washing as part of the strategy. Could you explain for our listeners exactly what reactivation is? Why is this commercially attractive for the company, and what does it mean for PFAS destruction?
Okay, those are two different things. So let's start with acid washing as the first opportunity. Bituminous coal-based carbons contain trace amounts of metals. Just because bituminous coal is from the ground and it contains these minerals. And in particular, arsenic is one that the EPA really looks out for. And so acid washing is a process where you take a granular activated carbon, even a powder, and you wash it with acid to remove the trace metals so that when you pass the dirty water through it, it won't extract. There's no more trace metals to extract into the clean water. Okay, so that is something that a municipal water site does what we call backwashing. They could backwash the carbon to remove the arsenic, but if we had no arsenic and did acid washing, then they wouldn't have to do that. So some cases it's more effective for us to provide a acid wash carbon. In other cases, the municipal water site can backwash, okay? But then they would have to have the footprint and the equipment to do that. So if we remove it, acid wash ahead, they wouldn't need to do that. So that's a value add for a particular municipal water site, okay? Reactivation, let's talk a bit about reactivation. When you use an activated carbon to remove a contaminant like PFAS, eventually the carbon is going to be filled with the contaminant and you cannot absorb anymore. So in the industry, we call that it's a spent carbon. So instead of throwing it away, landfilling it, we do what we call reactivation, where we take the spent carbon and we heat it up to high temperatures, and the PFAS or the contaminant will come off. We use a bit of steam to help strip off the contaminant. But once you strip it off back into the gas phase, you got to do something with a contaminant. So in PFAS, typically you have to destroy it. So that's the destruction step. So you desorb it from the spent carbon back into a gas phase, and then you destroy it. And in most cases, activated carbon producers use incineration as a destruction technology. So therefore, as you strip off the spent carbon and refresh the spent carbon, you could reuse it. So you don't have to start with a virgin carbon. So recycling the carbon is very important to the economics of the industry, and also will help in making sure that we can extend the supply chain so that it doesn't just depend on virgin carbon. So those are two value-added steps that we can that we're investigating as possible add-ons to our standard virgin granular activated carbon production.
And the Corbin facility, was recently announced to be, idled, but management has said it maintains, retains some meaningful optionality. Could you walk us through, what are the alternative product pathways that you're pursuing there, and what are the realistic timelines for these?
Yeah, that's a good question. I mean, when you talk about coal, you could talk about a material that contains high levels of carbon, and that could be used for certain things. And it also contains what we talked about, minerals, trace minerals and metals. And all three of those things, the carbon, the metals, and the minerals, are very valuable. We take the carbon part and we make activated carbon, but there's other things that we can do with the cleaned washed coal. The metals can be recovered as critical mineral matter and rare earth elements. And we can also use the carbon part as a purified coal for burning and creating energy. So we're looking at a portfolio of applications where the carbon or the mineral or the trace metals can be used as a value-added business. So we're looking at opportunities in mixing some of our carbon materials into asphalt. The asphalt industry is very interested in recycled carbon-rich materials, and so that could be a possibility. We have projects where we're looking at rare earth elements and critical mineral matter recovery. And also, we're also looking at the areas where we can take the pure carbon and work with a partner to convert it into synthetic graphite for energy storage applications. These are all require a lot of development, a lot of partnerships, and working with what I call lead adopters to help us pull ourselves into the marketplace. These things are in the development stages, require a lot of what I call demonstration, and we're thinking they're somewhere between 3 to 5 years off.
Okay, fantastic. Thanks for that, Joe. We're
Yeah.
getting close to closing here. So for both of you, a question. So finally, for investors who are weighing the risks and rewards here, like Eric, what gives you the personal confidence that the GAC problems are genuinely solvable? And Joe, for you, when production does ramp at economic scale, how durable is ARC's competitive position in what will be an increasingly contested market?
So maybe I'll go ahead and start. The what gives me confidence is that we're doing it the right way. We're stepping back. We're doing this in a thoughtful and rigorous way. If we do the engineering right, we're going to get a good result. I think we have a strong team here who can get this done. I think we're absolutely the right players to do this. We have the infrastructure at our Red River plant to support this process very well. We will be able to do it less expensively than anybody else. And I think we can do it in a very robust way. So I've been developing processes similar to this and like this for a very long period of time. This is very doable, and we have the right to do it. And so I feel very good about the way that we're going about this, and that the result is going to yield us the product at the quantity, the quality, and the cost that we need.
So let me add on to that. Although we have paused commercial production at the plant site, we haven't stopped interacting with customers, and we're being cheered on. The products that we're making with the different coal sources are performing very well in customer testing. They're still, we are able to make it at pilot scale, lab scale, and we're continuing the interactions with customers, engineering companies, consultants, and they're all saying that this is a product they want, and they're cheering us on. So I feel just like Eric, very confident that we'll be able to make this product at the volume, at the performance that we need to solve our customers' problems.
Okay, fantastic. So, Joe and Erica, this has been a great deep dive today, and we've covered a lot of ground. I really appreciate how you're able to, package what are very technical topics in a way that the non-technical people like myself can understand, and I think investors will really appreciate that, as well. So again, thank you so much, and I hope that both of you can join us again for a future event.
Thank you, Peter and Tim.
Thanks for having us.
Peter, thanks for the thoughtful questions. And gentlemen, thanks for joining us today to discuss ARQ. That was really a very interesting deep dive, and I appreciate the technical angle as well. So have a great afternoon. Thank you for listening, and don't forget to subscribe, as well as visiting www.watertowerresearch.com to stay up to speed on the company's small cap written research reports, podcasts, fireside chats, industry-specific symposiums, and conference schedules. We will see you next time for another edition of the WTR Small Cap Spotlight podcast. Finally, a special thanks to the producer and editor of the podcast, Krista Fitzpatrick.